My name is Robin, and I work at Klarna, as was said. Klarna is a large company. We have 7,000 people, half of them are developers, and the silver lining when we write code is maintainability and robustness. And today I would like to tell you how we achieve that, how I like to achieve this, and how you can eventually, hopefully, achieve that as well. Let me show you an example. We have a simple response to a request. Pretty easy, right? You have an action, you validate the request, you do something in the database, you log it, you return it. This is basically every app you've ever written. Like, that's it. However, this code you see right there, that's a liar code. That lies to you. It's pretty bad. What happens if validation fails? You don't know that. What happens if DB is unavailable? What if logging fails? You don't know any of this. You only looked at the happy path. And of course you do, because happy path makes you happy. But it's not what the business does. It doesn't tell you what happens if things go wrong. It doesn't tell you what even can get wrong. And as your application gets more complex, I mean, this is the boilerplate, but it gets more complex. It gets pretty unmaintainable, and it gets not robust, because you will forget about handling certain conditions. You will forget about translating this error state in this language or whatever. And I'm trying to tell you how you can solve that. And the solution is simple. The solution is functional programming. Don't leave. Don't leave. I know you want to leave. Everybody here wants to leave. So, this is a solution, and I know that you want to leave. There are two groups of people. The first group is people who hear functional programming, and they will be, oh, it's going to be academical, sometimes end of functors on monoids and all of that. And to you, I want to tell that I will not be talking about that. No monoids in my talk. I will not talk about that. I will use that, but I will not talk about that. And that's important. I think that when you start with something new, the terminology can be intimidating. And the solution I have is more visual, and it helps you, I think, wire your brain, even though you will be using the principles. The second group of people also wants to leave. And those are the people who use functional languages. They have their Clojure, they have their Haskell, Erlang, whatever. And they're like talking like, I have my happy place. I'm very, very comfortable. I can handle robustness. I can handle maintainability. I have all of that in my language. I don't care about you. And to you, I say, TypeScript is the only full-stack language. It's the only language that can actually run in browser. You can write web apps. You can write native apps. It's just omnipresent. It's there. And at Klarna, we take big advantage at having one language one person can write, and it can run almost anywhere. So what is my mission now is take something that these guys know and they love it, these structures, these ideas, and show everybody else and these guys how they can take advantage of them in TypeScript. So in the next 40 minutes, I would like to show how you can make maintainable code. I would like not to tell, so showing is important here. I will talk about TypeScript and why TypeScript is important. And then I will be coding. Yes, coding. I think it's important to see the code. And also, as was said, like Ricky had some live coding, and I want to try it on stage as well. So hopefully that goes well. These ideas are not completely mine. This is Scott Vlashin. He invented railway-oriented programming, the term. He had many presentations. He wrote a book. He had a very famous blog. However, he's focused on the F# community. He shows people who come to F# or are seasoned in F# how to write better code in it. And I read the book, and I really loved that. I read the ideas, and I was like, wait a minute, I can do that in TypeScript now too. So let's use that. So most of the things you will see here are just adaptations of well-known use patterns from other places in TypeScript. So let's talk about TypeScript. No, let's talk about railways. This is a code. I don't show the details because you would read it and get lost. By the way, there's a pretty cool thing. It's called Minimap Font. So this is just a code. You can write it and just have a bird's eye view of the code. I love that. When you execute the code, and yeah, you kind of go, let's say, from top to bottom. And it creates this kind of, let's call it a rail, maybe a line. And you go through it, and you have functions that appear there, and they change the data. And here, I'm kind of ignoring that in object-oriented languages, you technically don't pass data, but you change the data. So here it's more in a way that you take data and you apply transformations to it. And that's how your code looks like. If you look at the detail of such a one function, it's like, simple. It transforms apples to bananas, right? It's more like a factory, right? You have one input with tracks bringing apples and trucks leaving with bananas. Instead of tracks, it's directly on railway. A train comes in, you change it. When you put two of those functions next to each other or after each other, so one transforms apples to I got confused. Apples to bananas, and the other one bananas to strawberries. It's virtually the same, like for people standing on the edges, to having one function that just transforms apples to strawberries. This is the basics of composition, where you have these simple things. And when you make sure that right things come in and right things come out, it's pretty powerful. And we will be talking about this a lot. So composition is key in our place. Yeah. So this is the action I showed you before. Let's be honest, this is not a real word, as I said. It doesn't tell you anything. It doesn't handle errors. So let's add that. Wow. Do you even know what it does? Like, why? Like, catch, try, again? What is that? Like, are we sending things from it? Like, of course, this is complete, but it completely hides what is the intention of this code, because the error handling actually takes vast majority of the real estate on the screen. And you can see that, like, I put these functions at the places where you kind of do the transformation, the most important things. However, next to it, you have these explosions, completely derailing the train and just sending things to the user. And because it exits so early, you can't do anything about it. Like, if you eventually decide, okay, if the validation didn't pass, maybe I can use some default, maybe I will, fetch it or something like that. It's very difficult to see if you can do that, because it might have already blown away and it's returned to the user. So instead of that, we will do this little trick. We will add a second track next to it. So this is the idea. You have two tracks. One will have a train going through that in a success, and the other one will be for failures. This is going to be very explicit, as we will see, but I want you to have this mental image of two parallel tracks, one explicitly having success trains on it, and the other one with failed trains. And I will show you how it will help us to make the code maintainable and much more robust. So, how should it work in the code, right? Okay, what does it mean adding a second track? Do you write two files in once, or I don't know, whatever. No. The function I showed you had input and success. So let's add this second track of failure. It's a possible exit from the factory. An input comes in and either continues on the success track or is directed to the failure one. Then the code we have, and I put this now more horizontally because it's easier to look at it, you will have these functions one by one, and you will kind of take the errors from them. And as you see, only the successes will go to the next stage. But in the end, you have either all the successful operation or some of the errors. I can imagine that can be a little bit too abstract, let's say. So let's do some demo. First, I will talk about unions, because that's important. And I'm not talking about work unions here. I'm talking about TypeScript unions. I kind of assume you know TypeScript. At least you know that you can assign a type to a property. Here what I do is that this variable is either string or a number, And if I, for whatever reason, decide to put something which is not either, I will get an error. I can make things a little bit more strict by only allowing certain values. So for example, here, the value b can either be hey or ahoy. And if I would put anything else than these two literal strings, I get an error. This is, for example, useful maybe for code errors. You know, your application probably returns 200, 400, 500 errors, and you can make sure that nobody returns 421, I'm a teapot, when they shouldn't, right? However, this is for primitive types, for strings and numbers. What I want to show you here, I have a function, it's a little bit more complicated. I have function f, and it receives one parameter, which is an object using the same pipe operator as before for or, another object. What I know is that A will either have name or it will have a number, age. What it means is that if I check for it first, it's fine, I know it, and I can use it. But before I know which one is which, I cannot access it. What is kind of funny here is if I, for example, add something new here, let's say, let's say I, and you say it's a string, just here, checking for name, I can already see that it will tell me you can also access I, because I is, you check its name, therefore it has to be the first one, and not the second type of the argument. This is called, well, it's not, it's still a union, and you have to choose between one of those two types. So it's a choose type, one or the other. But this gets pretty weird eventually, and there is this pattern which makes things much, much easier, is if you name these two structures. For example, here I have a type person and type pet, because actually the age was not for a person, it was for a pet. And I explicitly add this literal string there. So every time I have a person, it has to have a tag with a string person and the other way. And what I can do here is that I can check for the tag, and I immediately know if I'm in this place or in this place. What I can do next is I can create this success, failure, and what I kind of call result is a combination of two. So success, for me, is an object that has a tag success, and it has a value of a type T. This is a generics. You can maybe imagine strings for now. I have type failure, which is exactly what we saw, but with failure, and again, type E, which is for, let's say, error message. And the result is one or the other. If I hover over that, you see that it has to have the string success. If I hover here, it has to have a string failure, and result is one or the other. We will see how that makes things much, much clearer later. But this is it. I just defined two tracks, kind of, here in those few lines. Now, back to the slides. You might be thinking, do you really need TypeScript for that? We just saw what Ricky did. He used some other things in JavaScript, and TypeScript, in the end, it's JavaScript. Before you said TypeScript, the only language that runs in a browser, but that's not true. It's JavaScript. Everything's JavaScript. So do you really need types in there? And the answer is no, but I do. What I mean with that? Of course you don't need that. In the end, every type you put there is not needed at runtime. That's the definition. TypeScript will remove it. All the types I put there are for me, are for developers to better understand the code. That is the maintainability part. So, of course, you don't need that. But without it, I will show you what I can achieve with these few simple lines, how much complexity I remove from my head by relying on this automated, well-executed tool that I kind of need that now. There are three things I believe TypeScript adds to this. It's self-documenting code. Again, that's having the types there, which, when well named, really provide a lot of value of knowing what's happening. It has exhaustive failure checking. These are the things I was talking about forgetting about some case. Maybe not forgetting, but maybe your colleague adding something which you are also needing, but you don't know about each other. Well, maybe not a colleague then, some other people in the company, because you know what your colleagues do. And then the last one is composing can be tricky. Once you start having these more complex types, it happens, and it happens very often, that you kind of compose them at the first try and doesn't work. Maybe you forgot to have the middle function that transforms things from bananas to apple, and you are trying to combine strawberries and apples directly. So, what I showed you was a little bit of a lie, right? No programming language. Okay, I will not. I'm not sure so completely. In JavaScript, you cannot have multiple return values, right? You cannot have that. You only have one input, and you have one output. The input can be array, which is like the parameters, but you can have one output. So what you kind of want is not this, but this. The functions have to work on both tracks at the same time. They need to have kind of two inputs and two outputs. So let's look at the detail here again. We have input, we have success, we have failure. We talk about that. But what is that thing down there? Also input. We need to have a thing that combines it together. Let me go through. Okay, yeah. I will show you code soon. What we need is to transform a function that looks like on the left to the one that looks like on the right, meaning having one input and having these two outputs to actually accepting the two outputs. And how we do that is that we will technically bypass the function if it's a failure track. I will show you what I mean. So let's use the result type. Just to remember, result is either success or failure. Now, we have a function that takes input and validates it. This function is the old one because it throws errors. So let's use how we actually use the types. And it's actually pretty easy. What we do here is that we create this new object. So instead of returning a new value, we just return an object. And then here, instead of throwing an error, we also return the object. And I completely understand why Ricky was not writing, but was rather only showing code. But I want to show you how easy that is. So that's it. I misspelled it, right? I completely transformed the old start function into a new style. Now, the typing is not right, because you see that the tag is a string, but that once you have that, when it collapses to string, you lose everything. So what we need to do is we need to type what is the return type, and it's a result, as you can see, and it's going to be a result. And if it's a success, it's a number, and if it's an error, we want it to be this exact integer. So, I mean, I typed the function like that, and you can see that TypeScript immediately understands there are no errors with this, so it works. I wrote the updateDB function in a similar fashion. Again, the input is the number we validated. The result is a date, because that's, like, let's say, when we finish this operation. Or it adds this error, right? Log function technically just logs things, so we don't have to touch it. Let's not go back to sites. Do we want to? No. What we want to create is this function called chain. What I mean with the chain is this adding two tracks. Let me look at it again. When I have validation, the input is number, not result. That's important. However, that's what you kind of want. You don't care like if it's not a result. So let's write this higher level function that transforms everything for us. And it's kind of easy. What we do is basically if result.tag is, is failure, success. Success, I run the function and return it. So it's like a far f on result.value. If it's not, I just return the result. I can use it like this, but I need something first. And this is the tricky part. I need to type my chain function. And I actually don't want to do that, and I already did it here. It takes some time to type it, and I will not say it doesn't. But the magic here is pretty amazing. Because when I have the chain function, it tells me exactly what I want. It receives a result, which is either a number or any error, and the result is a date, if it's successful, the DB unavailable, or any previous error that could have been there before. That's the F part. I have this here. And this is the magic. Like that thing there immediately surpassed so many like promises and everything. I will talk about promises later. I can do the same thing with T, and I don't have time to type it, but technically T does very similar thing. T meaning run the side effect like logging, and only if it's successful, otherwise bypass. And I can see that for log, it's value that returns void, but for tlog, it's a result that returns result. Maybe let's quickly look here. Update DB is input to result. Chained update is result to result. So we converted one track function that has two track output to two track functions. Now we will go back to slides. We talked about TypeScript, that I might not need it. And I think I showed you I do, because kind of combining these things is not easy. But you might ask, especially after seeing the previous presentation, aren't promises kind of doing this already? Like, isn't that, like, wouldn't it solve this problem? And the answer is no, never, absolutely not. And I will tell you why. Promises are meant for something completely different than what I showed you. Promises, in the first hand, have a limited API. Let's look at that. So how many methods do you have on promises? And the answer is you have one. You have then. And the other ones are just syntactic sugar. Like you can write them with that. You don't need anything else. You can't do much more than you can do with then. If you don't know why catch is syntactic sugar for then, we can talk later. But technically, that's it. You have one function. You have one way how to operate on that. You can't do anything else. And the combinators, sure, we have 4 of them. And some of them are kind of useful. Some of them are less useful. But that's it. Like once you want to have something more, it gets rather complicated. I recently wrote a library for throttling promises. So it's like a promise throttle all. And it's kind of like annoying to work with that. And it's still limited. But there's a bigger problem. And that is domain versus panic. And I'm talking about errors. Domain errors are errors in your business logic, expected. You know, when you put a validation in place, you want it to fail when the data is wrong. Like that's why you put it there. Like you want it to fail and protect you. You only have external systems. They can fail, but it's your decision to have these external systems, and you need to deal with the thing that with the decision you made. On the other hand, in programming, we have panics, you know, when there's nothing you can do. It's a programmer error, maybe it's an infrastructure error, whatever, but there's nothing you can do with that. In promises, you cannot distinguish between these two. There's no way. The catch catches all of them. That is a reason why when you create a promise, you can only type the successes, because that's the functions you write. But you cannot type the errors, because anything fails. Any type error will propagate to it and end up there. So you cannot distinguish it. And when you cannot distinguish, you cannot do exhaustive checks. Meaning, you don't know what's happening, anything can happen, and you will probably handle either too much, too little, or sometimes even both. I think we want to go to code for now. I have here a function action. And I will exemplify all of those things. It will come together now, hopefully. First thing, I'm using a function pipe, which is just a better way to say, take this, pass it through this function, then through this function, and through this. And you see, I use the validate, update, and log as I defined at the very beginning, and I change the update, and I t the log. Now, when I look at the response, I immediately see that the result is a date, which is coming from the update DB function if it succeeds, or it's DB unavailable or not an integer. So it combines all those errors. Now, let's say I want to handle those errors and translate them to, if it's an HTTP server, to response codes, if it's a Kafka to some other actions, if it's on front end to showing it to the user. But I don't handle that with that logic, I handle it later. And here is the beauty part. If I handle something which is not there, meaning maybe I have a code that's completely unneeded because I removed a check or something, it will tell me it's not there because it just cannot happen to be there. This is very, very useful when you have, for example, like a form validations, and you don't know, do I need this string that says this string combination is weird or this string is too long? You don't know that if you need it. You don't know if you need to translate it into all 50 languages your app supports. With this, it can tell you if you need it. On the other hand, it can also check that you handled all of those cases because it knows what those cases are. So for example, if for whatever reason I mistype, this code is now reachable, and I can have an error or some panic and tell it, Ops Genie developer fix this because the types tell you what to do. When I talked about why I need TypeScript, I was telling that sometimes combining things together can be a little bit tricky. And I will try to show you by going to the very up. And let's say that for whatever reason, okay, maybe it's easier that here the input is a string. This function works fine. It doesn't need it, actually. But I will get the error in here, and it will tell me that I cannot, it's kind of cryptic, I agree. But it kind of tells you that you can't do that. It's not assignable. You cannot put number to date. That's what it says. I'm not saying it's easier, but it catches the error. The other option is, okay, let me fix that. The other common thing is you maybe forget this chain method because, you wrote a function, you're so excited to use it, so you just put it there. And you get error again because you just try to use a two-track function and a single-track function after each other. It doesn't work. It tells you that. It kind of says that in a little bit cryptic manner, but it says result is not assignable to number, and that makes sense. So you chain it, and everything works. You have all of those beautiful things. Let's go back here. And I already showed some of that. So you don't want to write these utility functions yourself. Like this chain I wrote, it's a little bit like, you can do it, but it's some pain, and you can, forget about things. The same for the T. The pipe, I didn't show you, but to make the pipe work with types, that's pretty long. Like you have to, in TypeScript, write a pretty long definition of types. You don't want to do that. Plus, all these other things you can do with these types, there are so many of them. You don't want to invent them. So there are libraries, and for me, the one I use is called FPTS by Giulio Canti. It's an Italian mathematician. He created some awesome things, and this library is great. However, it has a few problems. First one is that it uses a different naming than I just shown you. So instead of having a failure and success in a result type, it calls one right, and the other is called left, and the combination is called either. And then there is this thing you remember that right is right, meaning like right is the success one. Yeah, I know, but that's how it is. And I don't think it's a big problem. What is beautiful about it is that it has a lot of those things. Like what I just showed you was the either, which is here. It has many other things for many other use cases. Once you will continuously explore this if you want, and you will eventually reach out to reader task either. And this is where the complete bliss goes, but I would need a small workshop to go there. But once in our code we had almost everything reader task either, it was awesome. Going back to the either, you see that there are many combinators, there are many constructors, destructors, instance operators, like the chain here I showed you before is right here. You have map, you have map left, all of these things are there. The problem with this library, and I will be honest here, is it's not a very helpful one, because when you click on any, flap is a variable from functor, and then you have this thing, and you kind of want to figure out what it means. It makes some sense. I mean, sometimes you have example. Wow, I'm kind of confused now. There's a surprise here. But very often you don't get that. And that's kind of the thing where the mathematician created something that works. It's complete, it's great, but we don't know how to use that. There are multiple resources online that help with that, and I can maybe link some of those. But this is something you should have in mind. Like, it's a great library, but the documentation sucks. Well, where did I heard it before? Like, that's not uncommon. Like, we will solve that. If you want to start with this thinking, I would completely recommend to buy this book, Domain Modeling by Functional, by Scott Lashin. I have it here with me. It's kind of my personal Bible. So many cool things in there, all of these things explained. It's F#, but I think that what I showed you, it's kind of easy to transform it into TypeScript and use it almost, I would say, anywhere. I think it's very well explained, and all that is pretty cool. Have you ever asked yourself, what is innovation? True innovation is difficult. People imagine that there's a lone genius. Isaac Newton during plague, going to countryside, sitting under a tree, inventing calculus and gravity, whatever. Well, he didn't invent gravity laws. It doesn't work like that. There is a quote. From Greg Settle, and it says, innovation is combination. This guy wrote a book about innovations. And I completely agree with that. What I'm trying to tell you here today is that we can combine these beautiful patterns that are tested, work from the functional world, combined with the TypeScript that we all have to use, and combine it together and have something that's like really beautiful that works well. Every time you try something new, let me read the quote. You have to master a new skill, but you're avoiding it because you know you'll be better at it when you do it first time. This is going to happen when you will go home and you will try FPTS. You will going to suck at it. It will not make sense. And I mean, it did for me. That's natural. But I would like to urge you, to take it as a prototype, It's like, I will show Robin that I can also understand that. And just play around with it 1 hour. Just try that. I mean, I have what I just showed you. My code is on gist. I will tweet it. Just go through it, run in your editor, hover your mouse over there, try to change things. And I think it will click. And eventually you will see the benefits. And you will have code which is robust and maintainable. And as I like to say, I mean, I made this kind of fun thing. T for TypeScript, T for train, robust code you will maintain.